Hello, everyone. It's a pleasure to have you all here. And it's my pleasure also to invite Professor Mauricio Dweck from Ansys, and he's going to present himself now for this webinar about remote teaching resources for active learning in STEAM, everyone says in one way, STEAM. And this is an initiative from the PAN-PBL Association for Problem-Based Learning and Active Learning Methodologies. And we hope to keep this kind of webinars regularly from now on. And we'd like to thank you all for being here, and mainly for Dr. Mauricio Dweck for presenting for us and share his experience in remote teaching with us. So I'm not going to take more of your time, just to welcome you on behalf of the PAN-PBL Association, and I give the floor to Mauricio. I don't know how you say your name in French, in English, Mauricio. Everyone must have an accent for that. It's a pleasure to have you here, Mauricio.
Thank you, Professor. Thank you, Professor Ulisses. It's a pleasure to be here. So I'm Mauricio Dweck. I'm Brazilian. That's why I don't have any issues with how Ulisses pronounced my name. And I'm very happy to be here and to have you all attend here this PAN-PBL webinar. And I will be talking about remote teaching resources for active learning in STEAM, science, technology, engineering, arts, and mathematics. The idea is to quickly present a few slides and have some opportunity to discuss with you. So please feel free to send us your questions via the chat facility. I'd like to have a Q&A at the end and obviously show you some more things if you're interested. I also want to acknowledge the assistance and the help and the contribution from Dr. Caitlin Tyler, my colleague here at Ansys, that helped me prepare this presentation. So let me just start by presenting myself. I have a background in materials sustainability and interdisciplinary teaching. I'm a graduate from the Polytechnic School of São Paulo in the materials engineering department, where I did my graduation project on a review of the curriculum that I followed. So I was already looking into engineering training and how it was being done at the time, many years ago in Brazil. Then I continued that research while I was doing my master's in production engineering at COPE in the Rio de Janeiro Federal University. And I looked a little bit deeper into the pedagogical and curricular issues of the Brazilian engineering education model. And I'm very happy to see that many of the things that I had looked into at the time are now in the new curricular guidelines in Brazil. And for my PhD, I moved back to materials. I moved a little bit more into sustainability aspects and how to integrate circular economy, the burgeoning criteria from circular economy in product design. Finally, today I'm an education development manager at Ansys, which you'll see I was formerly at Granta Design and now I'm part of Ansys. And I lead academic projects related to materials teaching, and I'm also the eco-design specialist, so I also lead projects in those. So the agenda for today, I'm going to start sort of situating the Ansys Grant Education Division and the work that we do and how we've moved from materials to STEAM teaching in many ways. I will then talk a little bit about active learning and remote teaching and how they can both benefit from each other in the times of crisis that we are living right now, this specific crisis that we have with the pandemic. And I will then go into the Ansys Granta Education Hub, which is a very unique online teaching resources website with a lot of resources for active learning, and this will serve as an example of some of the resources and tools that can be used to promote active learning in a remote context. And as I mentioned, we will have some time for a little chat, a little Q&A in the end. So let's start with the Ansys Granta Education Division. So Ansys Granta was founded in 1994. Actually, Granta Design was founded in 1994 by Professors Mike Ashby and Dave Sieben from the engineering department of the University of Cambridge. Professor Mike Ashby is very well known for his work in materials teaching and research. He's a legend in the field. And they were looking to develop a software solution for teaching materials. The company grew, developed software for teaching, for research, for the industry, and in 2004, it partnered with the American Society of Materials in order to continue its growth. And then in 2019, the company was acquired by simulation software leaders, Ansys, and we became the materials business unit in Ansys, and we support the different physics that Ansys develops for its software with the materials data, because materials data is important in many different areas. What's interesting is that we've kept our vision of material intelligence being important and being integrated throughout education, R&D, and the product lifecycle. So what exactly did we develop? What exactly was developed by Professor Ashby since 1994? If you're aware of his work, you might know this type of bubble chart. This was pioneered by Professor Ashby in many ways in his textbooks, and in some circles it's known as an Ashby chart. So what we did is we developed two different software, one for teaching, the Granta EduPack, which is now used in over 1,400 universities with over 100,000 students that access this as the main tool for materials teaching and material selection. But we also have Granta Selector, which is a more corporate version that's similar in its functions, which has been extended to meet the needs of the industry, and so it's a professional grade tool. Something that's quite unique and that has been maintained, and this is the whole focus of today's presentation, is that we have an education division within the company. So this was already the case in Granta, and it's still the case in Ansys. And we have teams that focus on product development, the development of the software. The university relations team, of which I am a part, that develops the partnerships with academic collaborators that we have, and the resource development team that develops resources for teaching and for learning. So this is something that I believe is quite unique to our company. And why? So why does material education matter, and why did we start with materials education? So Professor James Stewart was a pioneer of materials teaching back in his day, and he had just a few hundred materials at the time. And whereas today we have 200,000 engineering materials, so it's become much more complex to teach and to understand the properties of so many materials. So engineering professors have these new challenges: how to teach students to best use materials, how to deal with that much information. And in a sense, this is very similar to many different areas in science and technology. So materials has more and more become this overarching concept that can be used also for other scientific and technological topics. In the specific case of materials, and you will see that it also fits other areas, there are added dimensions of complexity, and this list keeps growing each time I'm making a new presentation, because Obviously, there are new disciplines that, this is the case with science that keeps evolving. There aren't simple materials anymore, it's material systems, and we'll see a little bit what I mean by that. Sustainability has become a much larger topic, and it's inherently complex. The internationalization of studies and of universities and the flow of students throughout the world also requires professors to have this common ground to teach the different topics that they're teaching. There's an increasing use of simulation tools, so software is getting more and more pervasive in that sense. And also something that we're seeing this year that we've seen grow very much is the virtualization of classrooms. So material science has evolved, and we have evolved with it. Basically, in more than 10,000 years ago, we started working with ceramics. Over 5,000 years ago, or 4,000 years ago, we were working with different metals. The readily available metals were being transformed in order to obtain alloys, and we started working with metals. And then much more recently, we started working with plastics and polymers. But all these areas, all these materials were dealt with separately. And today, what we are seeing is more and more, actually in the 1950s, we started considering them as a unit. So we started talking about material science. Let me get rid of this. And so today, when we're talking about material science, it's not only that science in itself, but it's also the different the different interfaces that this material science has with other fields of knowledge. In that sense, in the 21st century, we've seen an evolution of material science as well. And from the concerns of scientists and the concerns of the industry, we're not talking about materials as simple singular materials, but we're talking about systems more and more. And what we've been positing is that there's probably a need, whenever you're talking about materials, to address other areas related to materials as well. And these new interfaces are also adding to the complexity, but are also expanding the field. So materials is a great area if you want to teach different subjects, because they are present in many different disciplines. They're present in many different courses. So you can start with the thread of materials, and you can expand to virtually any area of human life, because materials are this omnipresent thing that we have to deal with. So if we focus now on the teaching aspects, what we've been developing in the Granta Education division and the software and the resources has been led by these 5 drivers recently. So the expansion of the materials world that we've approached, but also the fact that there's more and more data available, and you need to be able to go through that data quickly and find the relevant information to tackle real-world projects. So this is also something, being agile in this context. We've been working on this. Also, we've identified different teaching approaches. Most of the audience here today is aware of these different teaching approaches, and we've tried to cater to all of these. We're integrating sustainability and eco-design very much, and not only because this is a requirement, professional requirement, a requirement from the industry, and legislation is coming, and this is one of the main challenges of this century, but also because the students are coming more and more into their undergraduate studies expecting to be able to contribute to these fields. So they want their knowledge to be applied in projects that involve sustainability or eco-design. Then finally, and this is going to be one of the main focuses today, is how do we use technology in lectures? How does technology work more than just a tool, more than just a special effect, and work towards supporting new methodologies, especially active methodologies, self-learning, project work, etc. So what we've done is we've developed a software, obviously, Granta EduPack, which is the main software today for materials teaching. But it also is accompanied by a teaching and learning resources website. And I'm going to focus a little bit on these resources that we've developed, most of which are open access, some of which are only available to universities that have an active license. But I thought it would be an interesting contribution to this situation that we're facing now, trying to work remotely and trying to find the proper resources for active learning. So also to conclude on this first part about materials teaching and how it has expanded into STEAM in many ways for us. Obviously, we started focusing on material science and mechanical engineering when we started developing the software, but because of the interfaces with other areas, we now have tools, data, resources that cover a much broader spectrum of courses. And then you can start tackling, fundamental science in some aspects, but you can also tackle more creative, artistic endeavors. And we've done a webinar on artistic uses of materials and how, fine arts schools can also use our tools to focus on materials and materials teaching in a creative environment. And then medicine, also with bioengineering and medical devices that we've developed. So it's really much broader now than just materials, as I said. And the software itself, I'm not going to be focusing on it today. We can discuss this at a later time or maybe in the Q&A. It allows many different things to be achieved. This is just an overview of some of the main uses that the software has, but I will focus later on the teaching resources, which will also talk a little bit about the software. So let's go back into the main question of the hour: active learning and remote teaching, are they compatible? How can we make the most of both of these in this tricky situation, this tricky context that we are finding ourselves in? So first of all, let's go back into the question of engagement, because this is probably why we started looking into active learning in the first place, and the main difficulty that we're having now with remote teaching. What are the students engaging with? So if we're thinking about a generic learning process, the student comes with some previous knowledge, and we are trying to convey, transmit, propose a new topic knowledge. And in an ideal learning process, the previous knowledge will work as a scaffold, and the new knowledge will fit neatly into that, and you continue building on top of each other. But most of the time, we're in a non-ideal learning process, and there is a certain disconnect between the previous and the new knowledge, and you want to make sure that at least the structure still stays in place. Okay, so this is what we're trying to focus on, is how the new knowledge can be retained by the student. Okay, so active learning provides many different benefits. First of all, there's different types of active learning, and most of you here are probably aware. You can have discussions in the classroom, you can propose lab experiments, or you can have more structured problem-based or project-oriented learning. Ultimately, what you are going to be providing is an opportunity for more interdisciplinary work. You're going to be challenging the technical knowledge with real case scenarios and with applications of the technical knowledge into concrete examples and illustrations, which might help retain this new technical knowledge. And finally, it's an opportunity for acquiring specific professional methodologies, and this also means in an online or a software-based situation to acquire specific skills that are digital skills that our students need to acquire. But on average, what we've seen here from the World Economic Forum is that only 6% of adults today have demonstrated a high level of proficiency in problem solving in technology-rich environments. So we already have this sort of obstacle that we need to deal with, on top of using the actual technology to teach something. So this is the general context, and active learning has, and we have noted, has posed some challenges in the past. I mean, prep time is important. It might sometimes be more important than prepping for a lecture. And it all depends on the lecture and the activity. There's the fact that you are trying to integrate, some active time into a schedule that is already quite crowded. So this is also a limitation. So it requires some type of negotiation or some type of expansion or renewal of the schedules or the syllabi or the courses, the degrees in general. There might be some student resistance because, as we know, there are different teaching styles, but there is also different learning styles, and it's impossible to cater to everyone. And in some cases, that there might be some resistance to go into more active learning routes, and especially in countries where the high school level is more geared towards lectures, and so you might have more passive students coming in. And then something that is, again, the problem of the hour, which is finding the right tools and resources for remote work. How can we have active learning that works in this remote setting that we find ourselves in? In terms of the general areas of student engagement, some have been identified. So you have intellectual engagement, student-to-staff engagement, peer-to-peer, online, and outside of the classroom. So in normal times, they look sort of like this. Outside the classroom is not something that we will be focusing much on, but it's usually based on an inclusive university community and other things that can engage the student outside of the classroom. The sense of belonging that also can be a motivation to the student. There are the intellectual challenges that are posed to the student, the real world context that will be used as a material, and also the learning strategies that can be conveyed. In terms of student to staff, there's the feedback, the students' perceptions of the teacher's interest in the progress that can also be a source of motivation. In terms of peer-to-peer, there's the collaboration, the fact that working together is developing soft skills all the time, and also providing some more engagement from the students, and the discussions with diverse groups of colleagues are also an important source of engagement. And finally, the online part, which obviously fits our topic today, which is going to most of all encourage independence and self-learning, especially if you have sort of passive online or individual online learning, and the skills that come from the software and the tools used that we've already mentioned. Obviously, we could focus only on this, but this doesn't mean that the others are excluded because we're in a remote teaching environment. Because peer-to-peer intellectual and student-to-staff will continue to exist. So we're not excluding everything else. We're just sort of adapting them to this online setting, this online situation that can provide support for the other ones to still thrive. Again, if we're looking at teaching tools and learning methods, so this map that's adapted from Bransford and colleagues, we could be tempted to look at the technology enhanced part and say, yes, these are the tools that will be used in a remote teaching environment. So electronic tools, simulations, communication environments, and assessment opportunities with little tools for assessing. But that's not true. You can still have many different methods and tools that you would usually have in your regular classroom in this context as well. So basically, if we're looking at remote teaching, we need to sort out the content hosting, the interactivity management, and the evaluation tools. And there are options, many options, and maybe this is the most difficult part, is selecting the right tools for a given context and location. But first of all, we also need to consider, and I've seen examples of both, are we looking into a dedicated tool for each of these and dedicated for teaching purposes? Or are we going to leverage the student social networks that already exist? So in many cases, you might be looking at creating your own platform with a dedicated tool, or leveraging Facebook, which is something that most students are already using, or leveraging another social network that they are already using. And some professors have chosen one, and some professors have chosen the other. Also, the UNESCO has provided a list that you can check in their solutions page for assisting in this time of crisis with digital learning management systems that can be used. Systems for basic mobile phones, depending on where you are, because those will be the main tools available to the students, and the IT infrastructure is key. Systems with strong offline usability, even though we are in remote teaching, we can also work offline. MOOC platforms, self-directed learning content, collaborative live video applications, content creation tools, and the platforms that already exist with content that you can also leverage for your classes. So this is definitely something that you can explore, but it's beyond the scope of this presentation to look into. So now let's go into what we have developed along the past few years, and which has proven itself to be quite useful, especially in this context that we are mentioning today. So the Granta Education Hub is basically a website. You can go at grantadesign.com/education, and you will find here the Granta Education Hub. The teaching resources are here. Students have also access to their own student resources. We make this distinction because obviously, for instance, we don't want to give out the answers to the exercises to the students, so they don't have access to the same documents. And obviously, again, if your university has an active license, you can log in and have access to the full content, but you can also ask for support here as well if this is something that is interesting to you. When you access the portal, you'll be looking at the different documents by subject, by type, by language, and by level. So this is also an interesting entry point to find what you're looking for and what's relevant to you. So I'm going to start giving a few examples that can be used in remote teaching for active learning. The first thing is maybe one of the last ones we've developed, which is called micro projects. And if you're aware of the think, pair, share method, you'll see that this is very effective for that. So you're going. So the think, pair, share. Just very briefly, you're going to think of the answer to a question. You're going to pair up with someone to discuss your answer, and you're going to share that answer with the class. And this way, you have many groups, or you have many interactions that really make interesting answers bubble up from these interactions. And the idea is that we've looked to develop micro projects set around a specific engaging topic that can be easily adapted to this type of model, and obviously can be adapted into other models as well, but we think it works pretty nicely like that. So the first thing, the first example here, we have an example about zirconia, a ceramic that think it's a metal, so it's interesting to talk about zirconia. We also have other topics such as are bio-based polymers really greener than oil-based plastics? What was the material of the Viking shields? Is spider silk stronger than steel? Things that will maybe come up to the students' mind, like, oh, I've heard of this. Let me try to understand the inherent concepts that are behind it. And it will always be structured like this. We'll have a few kind of directed questions that can be that can be used with the software, and you will start with very simple questions that will start building into something more and more complex, and you will end with a broader exploratory question to really explore the underlying notions that fueled that material science question. And we've started developing sets with around 15, 20 micro projects for each topic. We started with material science and engineering, sustainability. I think there is one on bioengineering that has come out or will come out very, very soon. And we're constantly developing these. These first two were developed with Professor Ashby as well, so this is definitely something that he's still focusing on and that he still believes very firmly in. Another thing that can be used also is providing little challenges, small project briefs that can be interesting to motivate the students in this remote environment to work in a given illustrative example or project. So in this case, obviously, they will be developing, there will be that acquisition of new skills and that confrontation to intellectual challenges, but there will also be perhaps an element of peer-to-peer engagement that can be developed with these challenges. We've also developed a lot of case studies, and the case studies are great because and the feedback that we've had from professors is that this is the most useful part for them. The resources that they've been using more from the website, because they allow discussions. They can be used as a topic of discussion, especially in a flipped classroom environment. But they can also be used as an initial project brief or an exercise. So we've really developed case studies for applications in many different topic areas. We have a few simplified ones for introductory teaching and initial courses, but we also have some advanced ones that can also assist in those interfaces between different topics that was mentioned before. Again, intellectual challenging acquisition of different skills as well, and also good for peer-to-peer work. So here an example, we've been trying to package the case studies and the resources into packages, in the sense that we will put different files that will allow the professor to use it to structure a few sessions around a specific case, and then develop specific scientific concepts and in a more applied way. So always looking to get that example or application into the topic. The advanced case studies, I mean, here are just a few examples. There are more, and I think most, if not all of them, are open access, so you can definitely download them from the website. And this is great, again, to stimulate discussions with the students. And something a little bit newer as well that was developed is the 5-step method. And this is great to be conducted as a sort of jigsaw activity. So the jigsaw activity, if you're not familiar with, you start with groups, and these groups will have maybe a role distribution based on different parts of a project. So the example that we're going to give from the 5-step method for sustainability assessments is, if we're looking at maybe a life cycle assessment, there's the different stages of the life cycle of a product, and you can have different members focus on different stages. And the idea is that the groups will then split up and meet with their peers from other student groups, so that they can have focused knowledge groups. And then, based on what they acquire in these focused knowledge groups and the work that they develop, much as you could have in a real company, you would then get back into your own formation, your own group, and share the knowledge that you acquired, and building this sort of jigsaw in the process. So the 5-step methodology has been developed by Professor Mike Ashby as well, alongside other academic collaborators. And it's a very interesting way to address complex engineering and sustainability problems in a more systematic manner. And you'll see that it's quite, common sense in a way, and it could be applied to many different topics, and not only engineering projects or sustainability focused projects. It's basically, you're going to start unpacking the proposal, so unpacking the project prompt or project brief, and looking into the setting the objectives that you want to attain. Then you're going to look into stakeholder analysis of this project. There's a third fact-finding step. Based on those facts, you start forming a judgment. So you start analyzing and coming up with specific conclusions or specific advice that you can propose, or solutions. And you have a final step, which is reflecting upon what the work that you did, and figuring out what was achieved, what wasn't, and if there are improvements that can be made. And if you look into the jigsaw activity using the 5-step method, let's say you have an initial remit with the instructor introducing the project. Then you have the students that are separated in groups and start analyzing the different stakeholders. They can review that stakeholder analysis as a group or in class to assess the results. Then they could go back into their specific focused groups to find the facts for each of these stakeholders that they've identified, debate, synthesize, summarize what they've encountered, and get into a final reflection, which could be also open questions to the class, which can be a broader assessment in either a flipped classroom or just a round table or open debate with the instructor as a mediator. So this has that intellectual component that we mentioned. It also has a very important student to staff component and the peer-to-peer as well. So it's a very, very complete kind of situation. And as I've been mentioning, all of this can be conducted in an online environment using the tools that are available at the university. So the Education Hub will still have lecture units, other resources. You can definitely have a look. There's a wealth of information, a wealth of documents there. And I think if you're looking for additional support to implementing this type of activity, first of all, I think group work should be possible in a fully online format. Okay, I think this is something that should not be forgotten, because right now we are in this situation. So the networks are still there, the social networks. Students are still communicating. So we're aware that active learning is still possible, even in an online format. There are specific resources that the online remote format allows that maybe weren't as useful before and have become very useful today, such as videos, surveys, question banks, games. There are examples of gamified courses now that were maybe possible before, but that were really where the professors really invested their time saying, okay, this is the moment that I will be able to develop this. And then, there's a lot of online courses that are being developed and more, and those can be shared. So I think there's also the potential for building on other colleagues or building on other institutions' works and trying to come up with a more structured approach in the process. And then finally, in terms of the software support, here obviously there are some obstacles. First of all, you need server-based software solutions because of this remote setting. You don't have access to the university computers, so you need some type of external link. Local IT infrastructure can definitely be an issue. That's why there is that section in the UNESCO website with basic phones. Basic phone applications that can be used, but even our students, depending on the countries, they will have access to different models of computers, or they might not even have access to computers in their homes. So this is definitely something that has to be taken into consideration. This is not a one-size-fits-all situation. So professors know their context more than anyone else, and they are the ones that are aware of the possibilities. And I think the key takeaway here is that it is possible. How can we do it based on what's at hand? This will be a local solution. I wanted to mention that we have that we help coordinate the materials education symposium. This is basically a community of educators that gets together each year. It was an online event this year, and hopefully we'll have a physical event next year, but we might still have an online event next year, so feel free to join us. This is a great opportunity to help share these experiences. I know there will be a wealth of experiences being shared from this year next year, so it will be very good to have your contributions as well. Well, you can have a tour of the Education Hub. And my final remarks, I would say, I mean, there's a trend towards the digitization of learning processes that was already ongoing, but has been accelerated this year. This is a great opportunity, obviously, for active learning to deepen its coupling with technology, but we need to be aware of the technology gaps as well. So where available, this could be very practical, very good in many aspects. Using software and online-based resources can allow many different positive things, such as replicating examples, making them more palatable, move towards exploration and learning and fostering innovation, expanding the scope of activities, offering a virtual design lab solution to educators. This is all very nice, and this is the ideal world. And then there are the limitations. So there's a sense of urgency today, and there's a learning curve for many educators that cannot be underestimated. And sometimes the urgency is working against the learning curve because it adds pressure. There's the local IT infrastructures that have to be set up, and this can take time. This can take resources that sometimes might not be available. And then there's the software availability for different areas, which, different areas don't have software available for teaching. So there's probably some ground to be covered there. I think that's what I had to say. I think we still have time for some questions. I would like to thank you all for participating. I would like to thank PAN-PBL, Professor Ulisses Araújo, for inviting me, for setting this up. I hope this was an interesting presentation, and this can spark some questions and some collaborations. Thank you.
Thank you, Mauricio, for a nice talk and really complex. And I understand that people might have a lot of curiosity to know more about how this works in practical life. And so I will bring up the first question from Fernando Luis. Could you make a more detailed comparison between the Ansys platform and Moodle?
Okay, so I want to situate myself and most of what I presented based on this question. So I work for the materials business unit. We have our own software, which is part of the bigger Ansys platform. Ansys has what they call a campus solution, which provides research license and teaching licenses for universities. But the Granta software, which is the Granta EduPack, for instance, is something that is still separate because it's so recent, we haven't been integrated. In this sense, what we provide is software. So this is a tool. So for Ansys, you can have structural mechanics, you can have fluid dynamics, you have electromagnetism. In our case, you will have a materials database, you will have a synthesizer tool for material composites, you can do material selection. So all of these are tools. What you need is some type of use for these tools. Projects are a great use. And in terms of the Moodle, from my understanding, Moodles are more a content management system. So this is a way for you to structure your class, structure the assignments, structure the lectures, but the assignments can be done in an engineering software such as the Ansys software. So this for me is the main difference. One will be structuring the lecture, and the other will be more executing the exercises or the activities.
Okay, thank you, Mauricio. There are some two comments. Actually, congrats. From Alice, that is supporting your talk, and also from Professor Silvério Penin. And I don't know if we have any additional questions from the audience that I'd like to pose here. There was one former from Nasser from Algeria, but maybe it's missing a part of the.
Yeah, but I can give an answer to the part that is there. So how can he get closer to complex problems in eco design? There are different tools. For instance, there's life cycle assessments, and you have software specific for that. Our software also has a simplified eco audit, so life cycle assessment or life cycle inventory that can be performed, and there is more qualitative approaches as well for life cycle assessments and for eco design. So basically, looking into these tools, trying to apply them, and we have one specific case study, which is about plastic bottles and how can we, better design our bottles to avoid plastic waste. So there are some examples, and discussing the design of projects from an environmental point of view can also be an interesting way to start discussing eco design with the students.
Well, Fernando is back for you to in the follow up in your answer.
Yeah, so if the Ansys platform and Moodle can be integrated, I mean, sure. I just don't know what type of integration you were looking for. You won't be able to launch Ansys from within a Moodle, but you can definitely say in the Moodle, this is the activity you have to calculate the structure, or you have to run this simulation and provide the answers here in the Moodle as an assignment. So yes, you can work with both. It's not a problem.
Yes, if I can jump in the situation, I think you can use in parallel, right? Yeah. Like using, for example, Moodle or another platform in order, for example, to provide a video or an explanation, something that is complementary to the Granta pack, for example.
Yeah, exactly.
You can use both in the parallel way.
Yeah.
Now I think Nasser came with
the full question.
Full questions.
Yeah. So Nasser, my answer, my short answer would be: have a look at the case studies that we have. There's a case study on the materials for a tablet device, for electric vehicles, for plastic waste that I mentioned, and we're constantly developing new case studies, and those can definitely give you an idea of problems or projects that you can develop with your students in the selection of materials or the design of, or the eco design of products.
Mauricio, let me make a comment, because when we had a preparation for our webinar, you showed me. Of course, you didn't show today to the audience neither neither you can do it now. But you showed me in your platform an example of how you could move from one type of material and find different ways that you can find different materials, and depending the project you are working with. I thought that as really interesting experience. Can you talk a little more about that? How you manage? You might know what I'm talking about more than.
Yeah, I can show you. I think
We have
that's a good
left if you can.
opportunity to show a little bit more what I meant. This is the Granta EduPack. I think I need to share my screen again. Oh, here it is. So this is the Granta EduPack. I've opened a level 2 database, which is a generic engineering database for intermediate courses. There's a lot of information. I'm not going to go into that. You can see that there's materials data here in the browse pane that I just opened. But what really made the software popular is this chart and select tool, where you can take any property, and because we have different types of databases, you can definitely plot very interesting things. So I'm just going to plot, mechanical resistance versus, I don't know, thermal conductivity. And you can see here the different materials in the database as bubbles. And what's interesting is that if you want to start selecting materials and you say, okay, I want something that is strong and that is insulating, for temperature, and this might be, for building or whatever, you can take materials with a box here, and you can see that the other ones are excluded. You can even remove them, move closer, show the families that are here. So you have natural materials, composite materials, glasses, and polymers, and see that bamboo has a very interesting performance. You still have some composite materials here, hardwood, so in this case oak, and this would be silica glass. And you can start exploring like this, and each material will have a data sheet.
But so the students also can do this kind of gaming.
Yeah. This is meant for student work. So that's why I said we have project briefs, or we have micro projects that guide the student to use this. And then you can just say, okay, this is the situation. What is the best material? I did this over 10 years ago in my undergraduate studies in Poly for a material selection project, and this can complement all types of projects. So I see here that there's a question from Silverio about how can you use this in electrical engineering or electrical learning. There's many ways, because you can start selecting materials based on electrical properties, because you have all these properties here. And the deeper you go into the software, the more properties, the more materials you'll have, and the more complex your solutions will have to be. So this is just the tip of the iceberg. I would recommend anyone that's interested to go into the website, look at our previous webinars that we have done with different cases, or even just contact me, and I'll be glad to demonstrate a little bit more. But it's an example. I didn't want to focus on it because I was looking at more general approaches, but software such as ours, but other softwares as well, can definitely support the type of initiative for remote teaching that we mentioned today.
Yeah, that's good, because that's what you showed now. I saw before, and I think it's really an example of how you manage, and the students can do research and try to find different materials for the project, and you can adapt this also for the high school, I would say, depending on the level you are teaching, for example.
Yeah.
So, yeah.
There's over 500 high schools here in France, that use the software for specifically teaching about sustainability.
Yeah. So we are on time, 1 hour as we expected. I'm not going to say the time because everyone is on a different time zone. But in Brazil, it's from 11 to noon, and for you, it might be 4 p.m. right now,
Yep.
right?
Yep.
And so I thank you very much for your nice talk and openness to share your experience and the platform. But now Professor Cardoso has made a final question.
No problem. It's a pleasure to talk to Professor Cardoso, who's such a prominent figure from Poly. So I think this is part of what I meant with IT infrastructure. You need IT infrastructure, and you need server solutions for mass education. If you have those in distance learning, conventional distance learning, not just the remote teaching that we are having now, can benefit from this type of solution, because you have a software, you have a platform that is available to the students. It could be cloud-based. This is coming. This is one of the next steps. And then you have projects and you have assignments that will use the software. And especially if it's a software that will be interesting for their profession and the industry later on, then they are obviously developing the career skills that will be important as well. So I think first you have to develop the infrastructure, you have to develop the servers, and if that's possible, you join them on a project-led or project-based course with the software as its central point.
Great. So again, thank you all, and especially to Mauricio. I invite you guys. I know today we have a lot of people from the engineering field. So I invite you to visit our webpage, www.pan-PBL.org. We are advertising our next international conference that will be in Aalborg, Denmark, next August. We hope it will be face to face. But Aalborg also in the same time is organizing what they call the IRS PBL. They have a lot of focus on engineering, and they are launching by tomorrow a series of webinars related to engineering education also. So take a look at ucpbl.org from Aalborg University, and you'll be able to see the webinars they are promoting from now on. And also, please join us in the PAN-PBL Association and our next conference in Aalborg next year. And so, thank you everyone, and hope to see you soon in our next webinar. Thank you, Mauricio, and bye-bye.
Thank you.
The video will be available in our channel on YouTube. Thank you.